Welcome back. Today we're going to discuss some important concepts on graph theory. Already we have discussed the graph theory. So graph theory is a part of a data structure which has a vertex meaning a node which represent the objects and the edges representing the relation between each object or the entity. So graph is represented as a G. For example, we have a graph. What is a graph? A graph is a set of vertex and a set of edges. Here, vertex again is a set of vertices and edges or again a set of edges. Edges, set of all edges. Okay, right? So vertex set is already we might have some vertex v1 v2 v3 until v1 and sorry, not v1, it's a set of edges is e1 e2 e3 e1 e2 e3 until en. So these are the simple definition of the graph. Now let us discuss a small representation of a graph. I have a graph of a vertex A, vertex or a node, both are same, A, B, C and D. So here we have a G1, E2 and E3. Vertex set equals A, B, C and D. So there are four vertex we have. So that is that made the vertex set. And the edges we have three edges E1, E2 and E3. This is a small example of a representation of a graph. Now let us so now we discuss the type of a graph. There are four types of graphs we have. Number one, directed graph. Number two, undirected graph. And in directed graph again we have two types: weighted directed graph and the second one is unweighted graph. In undirected graph we have again two types, same like above: weighted graph and unweighted graph. So these are the four types of graphs we have. Now let me give an example of each type of graph, starting with directed weighted graph. Okay, right? So here I draw some sample graph. Say I have the graph with the node A, B and C. And directed graph meaning the edges are marked with the direction here, and we can say that we can able to move from A to B, but we cannot move from B to A, and the each edge are having some weightage. So weightage or the cost, it is a cost of the traversal from A to B or C to B. So here is 20 and 10 are the cost. So this is the weighted graph, directed and weighted graph. Second type we have unweighted graph, directed unweighted graph. Here also each edges are marked with the direction of travel or direction of travel or direction. Just simply simple terms you can say it is the directions. So here I mark that direction of edge E1 from B to A. Here the direction is clearly understandable that we can able to travel from B to A and not to A to B. And here there's no weightage. So this is a directed unweighted graph. Now let's go to the third one, undirected weighted graph. So here the edges don't have any direction, only it has the weight. Here we can travel in both sides from A to B or B to A or B to C or C to A. So there's no direction marked. So this is undirected and weightage. There's some cost between the travel A to B, say 5 and B to C is 7. And the fourth type is undirected weighted graph. Here same thing, we have a vertex ABC. Here we don't have any direction or we don't have any cost. So this is the undirected unweighted. Clear? Right. So here why I'm just taking only ABC like this. So it's just up to your choice. You can take any number of vertex and even any number of edges and any shape you can draw. Okay, this is for just teaching and learning purpose. I'm just using only 3 vertexes. Now let us discuss some important concept or important terminologies of the graph. Important terminology. Okay, it's number one, loop. Loop is concerned with the edges. Yeah, and loop, I mean an edge whose starts and ends in the same vertex. An edge whose endpoints are in same vertex. So that is called a loop. For example, I have a graph with the 4 nodes A, B, C and D. So in the vertex B, it has the edge starts and ends in a same vertex B. So here E4 is said to be a loop. If you see E1, E2, E3, the endpoints are not the same, but here the endpoints are same, E4. Then the second is multiple edges. Multiple edges meaning if there are 2 or more edges which has the same pair of vertices or same pair of vertex as a starting and ending point, then we can say that is a multiple edges. Here we can see E2 and E3 shares the same A and D as the endpoints. So E2 and E3 are the multiple edges. So definition, 2 or more edges having the same pair of vertex as the end points, then the two edges are called multiple each other or multiple edges. Here example E2 and E3 are the multiple edges. Clear? Very simple concepts. And the third one is the simple graph. Simple graph, the definition of a simple graph is so simple. The graph which has no loops or no multiple edges, then it is called a simple graph. That means you can't see any loops or any multiple edges in the graph. So it is so simple. That means each and every edges has different pairs of endpoints. For example, draw any shape with any number of node and any number of edges. So I have drawn the ABC. So here we don't have any loops, we don't have any multiple edges. Then I can say, or we can say, that the graph which I am showing is a simple graph. So with respect to the graph theory, it is the concepts are very simple to understand, right? I hope you understood. See you guys. Have a great day.